if you'd like. What aspect is most on your mind? Career, education, or something else?
Okay, tell me about the function of hippocampus.
The hippocampus is a key part of your brain for memory formation. It's crucial for turning your day to day experiences into long term memories and helps you navigate spatial environments. In other words, it's the reason you can remember where you put your keys or recall events from last week.
Okay, what's the function of amygdala?
The amygdala is like your brain's emotional alarm system. It processes feelings like fear, stress, and even excitement. When something feels threatening, it helps trigger that fight or flight response. It also plays a big role in attaching emotions to memories. So it's why some memories feel really intense.
All right, what's the function of give me any other part of the brain, just one name.
Let's go with the cerebellum. What would you like to know about it?
Okay, explain what it does. Why is it important?
The cerebellum coordinates your movements and balance. It fine tunes motor actions so that they're smooth and precise, like when you catch a ball or ride a bike. It's vital because without it, movements would be jerky or uncoordinated. Think of it as the brain's internal coach for smooth action.
Okay, tell me, is the spinal cord is the spinal cord connected with the brain?
Yes, absolutely. The spinal cord is directly connected to the brain. It's like a superhighway for information. It carries signals back and forth between your body and your brain. Everything from reflexes to sensation to motor control. It's essential to your whole nervous system.
So, what's the first part of the brain that is connected to the spinal cord?
The first part of the brain connected to the spinal cord is the brainstem. It's kind of like the bridge. The brainstem controls a lot of your automatic functions, like breathing and heart rate, and it's the hub where signals move between your body and brain.
And what are the other things apart from the brainstem that are connected directly to the spinal cord?
Besides the brainstem, nothing else is directly connected to the spinal cord. The brainstem really is the main link. From there, the rest of the brain, the cerebellum, the cerebral cortex, and so on, communicates with the spinal cord through pathways that pass through the brainstem. So the brainstem's the key connector between the spinal cord and the rest of the brain.
Okay, so tell me uh, about the primary functions of occipital lobe.
The occipital lobe is your brain's visual processing center. It's responsible for interpreting what your eyes see shapes, colors, movement. So when you look at anything, the occipital lobe helps you recognize it and make sense of the visual world around you.
And what are the functions of the temporal lobe?
The temporal lobe plays a key role in processing sounds and understanding language. It's also essential for forming long term memories, thanks to the hippocampus tucked inside. Plus, it helps you recognize faces and objects. So it's a multitasker for sound, memory, and recognition.
Is the parietal lobe situated above or is it the temporal lobe?
The parietal lobe is situated above the temporal lobe. It sits more toward the top and back of the brain, while the temporal lobe is lower along the sides. They're neighbors, but stacked in that way.
I don't understand exactly how how these are located. So give me a better explanation.
Sure. Imagine looking at the side of your head. The temporal lobe is down near your ear, along the sides. Now, above that, more toward the top of your head, you'd find the parietal lobe. So, if you drew a line across the top of your ear, the parietal lobe would be above that line, and the temporal lobe below it.
Okay, so temporal lobe is more towards the sides of the brain, on both of the sides of the brain, left and right.
Exactly. The temporal lobe sits on each side of your brain, just about where your temples are, on both left and right.
And above that is the parietal lobe.
You got it. Right above the temporal lobe, you'll find the parietal lobe. They're stacked vertically, so the parietal lobe handles things like spatial awareness and touch, sitting right on top of the temporal lobe.
And temporal lobe is responsible for memory, for, is it?
Yes, that's right. The temporal lobe plays a big role in forming and retrieving memories. It's where structures like the hippocampus are located, which help turn experiences into long term memories.
Okay, so hippocampus sits in the temporal lobe.
Exactly. The hippocampus is tucked inside the temporal lobe, doing its memory magic right from there.
So does the hippocampus store long-term memories or short-term memories or both?
The hippocampus is key for forming long term memories. It takes your short term experiences and helps consolidate them into long term memories. Once stored, though, long term memories are more distributed across the brain. So think of the hippocampus as the organizer that gets them ready for long term storage.
And the brain stem is situated in the temporal lobe.
No, the brainstem isn't in the temporal lobe. It's actually lower down, at the base of the brain. It connects your brain to your spinal cord and manages automatic functions like breathing and heart rate. So it's more central, underneath everything else, rather than tucked into a specific lobe.
And the hippocampus sits inside the parietal lobe.
No, the hippocampus isn't in the parietal lobe. It's nestled inside the temporal lobe, so down more toward the side of your brain. It's right there where it can help with memory formation and spatial navigation.
So what are the things that parietal lobe is responsible for?
The parietal lobe is all about processing sensory information. It helps you feel touch, temperature, and pain. It also plays a big role in spatial awareness, like knowing where your body is in space. Plus, it helps with tasks like math and reading by integrating sensory input. Pretty handy area.
So the parietal lobe is responsible for the mathematical functions of the brain.
It definitely contributes. The parietal lobe helps with numerical processing, like understanding quantities and performing calculations. Of course, it works alongside other brain regions, but it's an important piece of that puzzle.
So what are the other constituents of the brain that we have not yet talked about?
We've covered a lot, but we haven't really talked about the frontal lobe, which handles reasoning, decision making, and voluntary movement. There's also the limbic system beyond just the hippocampus and amygdala. Think the thalamus and hypothalamus, managing sensory relay and homeostasis. And of course, the corpus callosum, connecting the two hemispheres. Brain's got quite a network.
Okay, so tell me about all of the things that we have yet not discussed. Just give me one name and explain it, and then give me the other name, the next name, and then request for my permission to explain that thing, and then do that for every subsequent thing.
Let's start with the thalamus. The thalamus is like a relay station, passing sensory information, except smell, to the appropriate parts of the brain. Now, may I explain the next one for you?
Explain thalamus one more time, simplified and complicated both, and then ask me for the permission to move.
In simple terms, the thalamus is like a central hub that directs sensory signals, like touch or vision, to the right part of your brain to interpret them. In more complex terms, the thalamus is a deep brain structure that filters and relays sensory and motor information to the cerebral cortex, playing a key role in consciousness and alertness. Now, may I move on to the next part?
So the thalamus is basically associated with sensory reactions and consciousness, isn't it?
Yes, exactly. The thalamus is closely tied to routing sensory input and playing a role in keeping you alert and aware. May I introduce the next brain structure?
Yes, but what is the next brain structure?
The next structure is the hypothalamus. May I explain what it does for you?
Yeah, go ahead. I said go ahead, do it.
The hypothalamus is like your body's regulator. It keeps things balanced, controlling hunger, thirst, temperature, and even hormones. It's a link between your nervous system and your endocrine system, keeping everything in homeostasis. Now, would you like me to name another structure next?
What's homeostasis?
Homeostasis is your body's way of keeping everything stable inside. Things like your temperature, blood pressure, and energy levels. The hypothalamus helps adjust those internal conditions so that you stay in a healthy, balanced state. Now, may I share another brain structure?
What's limbic system?
The limbic system is a group of structures in the brain involved in emotions, motivation, and memory. It includes the amygdala, emotion, hippocampus, memory, and others. It's like the emotional and memory center. Now, would you like me to name another piece?
Repeat that same information, please, and try to exemplify everything.
The limbic system is a collection of brain structures that handle emotions, motivation, and memory. For example, the amygdala helps you feel fear or excitement, like when you're startled or happy. The hippocampus helps store memories, like remembering your last birthday. So it's that inner network that gives emotional meaning to your experiences. Now, may I name the next part?
Yeah,
The next one is the corpus callosum. Would you like me to explain what that does?
sure.
The corpus callosum is a thick band of nerve fibers that connects your brain's left and right hemispheres. It's like a bridge, allowing both sides to share information. For example, coordinating complex tasks that involve both logic, left side, and creativity, right side. Now, shall we move on to another structure?
Repeat it one more time, please.
The corpus callosum is a bundle of nerve fibers that links the left and right hemispheres of your brain. It's like a communication bridge, allowing both sides to share information. For instance, when you're doing something that needs both analytical thinking, left, and creative thinking, right, the corpus callosum helps both sides work together.
Exemplify analytical thinking and creative thinking.
Sure. Analytical thinking might be something like solving a math problem or planning a budget, breaking things down step by step. Creative thinking, on the other hand, could be writing a poem or coming up with a new design, using imagination and innovation. The corpus callosum helps integrate both, so you can problem solve with both logic and creativity. Now, may I introduce another structure?
So, what you're saying is that left hemisphere is responsible for the analytical functions, the memory, the practice that you have done over the years, over the course of time. It puts all of those things into application, whereas right hemisphere is responsible for creating new things that do not exist.
That's pretty close. The left hemisphere often handles more logical structure tasks. Things like language, math, and patterns, often drawing on learned skills and experience. The right hemisphere is more tuned to creativity, imagination, and spatial tasks, like coming up with new ideas or seeing the big picture. But both sides work together, blending your experience with new ideas, so it's not a straight split, more like a collaboration.
All right, name the next brain part.
The next one we can talk about is the cerebellum. Would you like me to explain what the cerebellum does?
Sure.
The cerebellum is your coordination center. It fine-tunes your movements, making them smooth and balanced. Like when you walk, catch a ball, or even keep your posture. It doesn't initiate movement, but it makes sure you move gracefully. Now, would you like me to introduce another part after this?
Yeah.
Next up is the basal ganglia. Would you like me to explain that?
Yeah, sure.
The basal ganglia are deep brain structures that help control movement. They assist with starting, stopping, and smoothing out voluntary motions, like when you decide to pick something up. They're also involved in habit formation. Now, would you like me to introduce another part?
Where is basal ganglia located? Where's cerebellum located?
The basal ganglia are located deep inside the brain, near the center, kind of nestled around the thalamus. The cerebellum, on the other hand, sits at the back of the brain, just underneath, almost like a little mini brain, behind the brainstem. Now, would you like another structure introduced?
Yeah.
The next one is the brainstem. Would you like me to explain that again, or would you like to move forward?
I'd like to move forward.
All right. Whenever you're ready to dive into anything else, just let me know.
What are the other parts? Tell me about the other parts. Where is thalamus located? What's thalamus?
We've already covered the major structures, but just to recap, the thalamus sits near the center of your brain, above the brainstem. It acts like a relay station, channeling sensory information to the correct parts of the cortex, and it's involved in regulating consciousness and alertness. If you're curious about other regions or need further explanation on any we touched on, just let me know.
What about What about there's a thick membrane, liquid membrane inside the brain.
You might be thinking of the meninges. They're protective membranes covering the brain and spinal cord. Between them, there's cerebrospinal fluid, which cushions and nourishes the brain. It acts as a shock absorber and helps clear waste. If that's what you meant, that's its role. Let me know if you want to explore anything else.
Sometimes I get headache, and what happens is that I kind of feel like the inside of my brain is a separate thing which is hitting the skull and it hurts. What is it?
That sensation can be pretty uncomfortable. While it might feel like your brain is bumping into your skull, the brain itself doesn't have pain receptors. Headaches often come from tension in muscles, blood vessels, or the meninges we mentioned. It's your body's way of signaling something. Maybe stress, dehydration, or other triggers. If headaches are frequent or severe, it's always good to check in with a doctor.
What is cerebrospinal fluid?
Cerebrospinal fluid, or CSF, is a clear fluid that surrounds your brain and spinal cord. It acts like a cushion, protecting your brain from jolts or impacts. It also helps deliver nutrients and remove waste. Basically, it keeps your brain buoyant and protected inside your skull. So it's pretty essential.
So it protects the brain from jolts, jolts, and it keeps your brain buoyant, buoyant. What does that mean?
Exactly. When we say it protects from jolts, it means if you bump your head or move suddenly, that fluid cushions your brain so it doesn't hit the skull directly. And buoyant means it makes your brain float slightly inside the fluid, reducing its weight and pressure on the base of the brain. It's a natural protective system.
So buoyant means it makes the weight and pressure on the base of the brain. It's a natural protective system. It keeps the brain float,
Exactly. Buoyant means
buoyance.
goodbye. If anything else comes up, I'm always here. Take care.
So list the names of the things that we mentioned about the brain in this
We
conversation.
I can't list things from this conversation right now, but if you'd like a recap, feel free to ask again, and I'll give you a fresh summary.
Is there a thing called medulla inside the brain?
Yes, the medulla or medulla oblongata is part of your brainstem. It's at the base of your brain, just above the spinal cord. It controls vital automatic functions like breathing, heart rate, and blood pressure. It's pretty crucial for keeping you alive without you even thinking about it.
What are the other things around medulla oblongata?
Around the medulla oblongata, you'll find the rest of the brainstem structures, like the pons, which helps with breathing and communication between different brain areas, and above that, the midbrain, involved in things like vision and hearing reflexes. All these structures together manage automatic functions and act as a relay between the brain and spinal cord.
Tell me more about pons. What are they?
The pons is a part of the brainstem that sits just above the medulla. It's like a bridge connecting the cerebrum with the cerebellum. It helps with functions like breathing and sleep regulation, and it also relays signals that coordinate movement. In other words, it's crucial for communication between different regions of your brain.
What are the parts? Other parts? I mean, tell me about the vocal auditory channel. What are the parts that are there in the auditory vocal channel. Let's just talk about the vocal channel. Let's talk about the alveolar ridge, the palato-alveolar ridge, retroflex region. Let's talk about those things. So let's begin. Let's begin with retroflex sounds, how they're produced, and give me words examples.
Retroflex sounds are produced by curling the tip of your tongue back toward the roof of your mouth, usually near the hard palate or the alveolar ridge. They often have a rolled or curled quality. For example, in some languages, the R sound can be retroflex. In certain Indian languages, like Hindi, a retroflex T or D is used, like in da, retroflex T, or da, retroflex D. These sounds are distinct from more common dental or alveolar sounds. Let me know if you'd like to explore another part of the vocal tract.